Hi. Okay. So, this is the last episode for chapter wave. In this episode, we will discuss about simple pendulum. Simple pendulum is nothing but a, system of a string of length L and fixed with one end to a rigid support, and another end is fixed with a metal bob of mass m, and let it to be suspended freely in air through the support. Okay, so the force of gravity, gravitational force, is acting on the mass bob. So we can draw a direction of weight directly toward downward direction. So this is the diagram of simple pendulum, and L is the length of the string, and the force of gravity acting downward direction, this is the weight, is equal to mg. And due to this force, force per unit length developed on the string. Therefore we are writing this force per unit length as tension T. Okay, so due to this tension on the string, according to Newton's third law of motion, we know that every action has its equal and opposite reaction. Therefore, opposite to tension, there is another component, another force acting on this direction, that is equal to what? Mg cos theta. This is angle theta. This angle is obtained from here. See, uh, these are the two parallel lines, and this length of the string, length of the pendulum, acts as a transversal. Therefore the angle at the tip of the pendulum is equal to the angle here. So this is angle theta, and this is the base component of the vector omega, the weight. Okay, it is mg cos theta. Okay, mg cos theta. And one restoring force is acting on the bob or in the pendulum. That is, restoring force is always directed toward the mean position. So this is the force acting on the pendulum. So this force will restore the pendulum to its in equilibrium position. So these two forces are perpendicular to each other. That means mg cos theta and this force is perpendicular to each other, and we get another component of this force, weight, okay, as mg sin theta. So it is the vertical component of the weight, so it becomes mg sin theta. So it will be convenient to solve the derivation of simple pendulum using torque and angular displacement. Here angular displacement is equal to theta, and torque at the support at this point is equal to the negative of each other. That means torque is acting against the angular displacement. Therefore torque acting is equal to L. L is the length of the pendulum, and the force is equal to mg sin theta. Here theta is the angular displacement and torque are oppositely directed. Therefore we will put a negative sign here. Also from Newton's law of rotational motion, we have tau is equal to inertia multiplied by angular acceleration. Inertia multiplied by angular acceleration. From these two equations we can write inertia multiplied by angular acceleration is equal to minus L sine theta. Okay, so alpha is equal to m g, mass of the bob, g, acceleration due to gravity, L, length of the string, divided by inertia, multiplied by sine of angular displacement. So from mathematics we have sine theta is equal to theta minus theta cube by 3 factorial plus theta 5 by 5 factorial, like this. This is a sine series. Okay, so this is a sine series. So we will consider only sine theta is equal to theta because here angular displacement is very small. Angular displacement is very small, and if we cube or take fifth power of angular displacement, it will be a very small quantity, that is negligible quantity. Therefore we will take only sine theta is equal to theta. So theta is in radian, so expression for angular acceleration become what? It is m mass acceleration due to gravity, length of the pendulum, and divided by inertia, multiplied by angular displacement theta with a minus sign. So angular acceleration and angular displacement are oppositely directed, both act in different direction. So the negative sign expresses this. So again, by the relation of angular acceleration and angular velocity, we have angular acceleration is equal to angular velocity multiplied by angular displacement. We have this. Okay, so angular acceleration is equal to angular velocity multiplied by angular displacement. So here if we write one step forward, then angular acceleration divided by angular displacement is equal to minus mgl by I. Then we can write angular velocity is equal to, this is square. Okay, so here we can write omega squared minus mgl I. I am dropping here negative sign because here it becomes omega square, and omega square value is always a positive quantity. Therefore omega is equal to under root mgl by I. So angular velocity or angular frequency also same, both are same. So angular frequency is equal to mgl by I. So it becomes twice pi nu is equal to under root mgl by I, or we can write in terms of time period is equal to twice pi by under root I by mgl. So we obtain both the term frequency of the simple pendulum or time period of the simple pendulum. So time period of the simple pendulum depends upon what? Inertia and length of the pendulum. Okay. So on simplification, we get expression for time period is equal to twice pi by under root L, where L is the length of the pendulum and small g is the acceleration due to gravity. So using simple pendulum in the laboratory, we can calculate acceleration due to gravity of the earth. Okay.